Good morning, children. Last time we had learned how to write a chemical reaction in a form of a chemical equation, and also we learned how to balance a chemical equation. I know it will take time, but slowly you'll be able to balance the chemical equation. In this chapter, number of equations will be there. If you practice those equations, if you practice them, how to balance, you will learn how to balance the equation. If you keep on practicing those equations, you learn how to balance the equation. Now, when you write a chemical equation, these are the following information that you get. You come to know the reactants that are taking part in a reaction. You come to know the product that has been formed. You come to know the elements that are present in the reactants as well as in the product. You also know the number of atoms. When you write the balanced chemical equation, you come to know the number of atoms of each element that are present in a chemical uh, reaction. And of course, you can also calculate the mass of the substances that are present in that particular reaction. And how to calculate the molecular mass or the formula mass, you've already done it in class 9. Now, these are the basic information that you get when you write a chemical equation. You can make your equation more informative in nature. Now, how you can make your equation more informative in nature, this is what we are going to do today. You can mention the physical state. You can mention you can tell in your equation whether the reactant or the product is solid in state. So you write small s. If it's liquid, you write L. If it's aqueous, you write AQ. Aqueous means it is dissolved in water. Gas, you can write G. If gas is evolved, that is in the product, a gas is evolved, then you can put the symbol and arrow pointing upward. If product form is a precipitate, precipitate means a substance which doesn't dissolve in water. So you can write S, you can write an arrow pointing downward, or you can write PPT, a precipitate is informed in the reaction. Then if substance is it has more of water and less of that particular substance, it is said to be dilute. You can write DIL in front of it. If it has less water and more of that particular substance, it is said to be concentrated. Then you can write CONC, like you must have heard dilute acids and concentrated acids. Dilute sulfuric acid, which means acid is amount of acid in dilute sulfuric acid is less, water content is more. If it's concentrated, then concentrated, it has less water and more of that particular acid. Here are certain examples. You can see zinc is in the solid state. Sulfuric, it's dilute, more water, less acid. The product form, it's aqueous. That means it is completely dissolved in water. Gas, an arrow pointing upward, is been evolved in the reaction. Second one, copper in the solid state. Nitric acid, aqueous, more of water is present in it. Copper nitrate, the product form, it's aqueous. That means it is completely dissolved in water. Gas, nitrogen dioxide is evolved. You can write G also, or you can, this arrow symbol you can also put this arrow symbol out here pointing upwards. Then water, it is obtained in the liquid state. Barium chloride here, aqueous form. So barium chloride solution, when we say, it's an aqueous form of barium chloride. Barium chloride is dissolved in water. Sodium sulfate in water again, so it's aqueous. Barium sulfate is formed as a result of these, as a result of their reactions. And this arrow pointing downwards, it indicates a precipitate is formed. That means barium sulfate doesn't dissolve, it settles down, right? And sodium chloride, aqueous form of sodium chloride, that means sodium chloride is completely soluble in water, right? So this way, when you mention these conditions in your reaction, in your equation becomes more informative in nature. Then certain reaction takes place in some specific condition. They need certain temperature, certain particular temperature, pressure, catalyst. Now, what is catalyst? Catalyst is a substance which when added to a particular reaction does not take part in the reaction, but it can alter the speed of reaction. Alter the speed of reaction means it can either increase or decrease as desired. So here nitrogen gas reacts with hydrogen gas and it forms ammonia. Now these two reacts under these specific conditions, that is a temperature of 500 degrees Celsius, a pressure of 500 atmosphere, and Fe written iron acts as a catalyst, right? So this specific conditions are required for these two to react to form this product, right? So whenever these two are going to react to form this product, these are the specific conditions required. Then another way to make your equation more informative is to see whether the heat is being evolved or absorbed. Based on that, your chemical reaction can be classified as exothermic and endothermic. Exothermic, when we say, exo means to give out, thermic is the heat. So when heat is released into the surrounding, the temperature of the surrounding will increase, and such reaction is said to be exothermic reaction. Endothermic, endo means to absorb, and thermic is the heat. When heat is being absorbed, the energy is being absorbed from the surrounding, then it is said to be, and the temperature of the surrounding, it drops down, then it is said to be endothermic reactions, right? Now some examples. Endothermic, where heat is absorbed. Photosynthesis is an example, very common example. Plants absorb heat energy from sunlight to convert carbon dioxide and water into glucose and oxygen. So carbon dioxide, water vapor reacting, they are taking the heat from the sunlight, right? And forming the products. When heat is absorbed, then the heat is written towards the left hand side, that is along with the reactants, right? Carbon, next one, calcium carbonate. It takes a lot of heat and it decomposes to form calcium oxide and carbon dioxide. So heat will be written along with the reactant. In place of heat, you can put this symbol also, right? Oxygen, nitrogen, heat, they're absorbing the heat to form NO. Now in some reaction, sometimes this heat is written along with the product. But if it's an endothermic reaction, then a minus sign will come if it is written with the product, right? Next is exothermic, where heat is released. Combustion, burning of crackers, burning of candle, all this release lot of heat into our surrounding. So they are said to be an exothermic reactions. Here methane, this is methane, reacts with oxygen to form carbon dioxide, water vapor, and give out heat. So heat this time will be written along with the product. Respiration is also considered as exothermic reaction. In respiration, glucose reacts with the oxygen that we breathe in, and this produces carbon dioxide, water vapor, and again, a lot of heat is being produced. So this is also an example of exothermic reaction. So in your balancing of cause is very important. Then if physical states are being mentioned, some specific conditions for a particular reactions are being mentioned, or involvement of heat, either the heat is absorbed or released. If it is shown in a chemical reaction or in a chemical equation, then your chemical equation will become more informative in nature. And if it's there, we also get better information under what condition the reaction is taking place, what are the physical state of the products that are being formed, Then what is the energy requirement? So this gives more information, or you can make more informative. Equation can be made more informative, right? So that's all for today, children. Now, last time I gave you some reactions to balance certain reactions, and I have shared the answer key. You can go through it. And again, I've given some more questions, so please practice those questions, right? Now, have a nice day. That's all for today.